All right. Hi, everyone, and thank you so much for joining us today. My name's Hannah, and I'm an account manager at Prolifics. For those of you who aren't familiar with us, Prolifics is a solutions provider, and we've spent 30 years working closely with IBM as a platinum partner, and we are one of only 10 IBM Global Elite partners. So we provide engineering and consulting on a range of projects from cloud native development and data and analytics to integration, which is our longest standing practice. So we thought that looking at how event-driven patterns fit into the wider integration story felt like the perfect opportunity for us to work with IBM on this solution. Prolifics works with some of the UK's largest retailers, and we are very attuned to the challenges felt by our clients, particularly in recent months. And what we continue to see is clients who are looking for solutions that go beyond just improving their existing processes. Instead, they're looking to create new experiences for their customers. So we're very excited about the potential of Event Streams to deliver some of these transformations. And with that, I will hand over to Jamie Frampton.
Thanks, Hannah. So just before we begin, we'll have a couple of really expert speakers today. One being Alan Chatt, who's our offering manager for Event Streams. The other is not myself. It will be Kim Clark, one of our integration architects, who will talk a little bit later in the presentation. We'll have a little Q&A session at the end. So please, if you have any questions, ask them at the end. If there's anything key that you want to ask during, please feel free. The session is recorded, so we can send it out afterwards. So with that, I will pass over to Alan to kick off with what is Event Streams.
Thanks, Jamie. So, hello everyone. As Jamie introduced myself, my name is Alan Chatt. I'm the offering manager for Event Streams. And there's two main things that I was going to take us through today. So the first one is starting to look at new event-driven integrations that are emerging, talking about what they are, why they're important, and how that relates to the kind of technologies that we're picking and we've adopted as part of Event Streams to underpin them. And then secondarily, I was going to take us through exactly what we've done with Event Streams, what we've built around Apache Kafka to make it essentially enterprise ready, before handing over to Jamie to share some broader experiences that we already have working with retailers around this technology. So let's jump straight in with this first event-driven integration pattern. Essentially, there are three what I would think of as top-level patterns that we see technologies like Apache Kafka enabling within clients, and they're becoming increasingly important in the way that we are building new applications. So the first one is really, I think of it as kind of high-speed data distribution throughout the enterprise. And what we see emerging here is that rather than like applications that need to make heavy use of data that already exists in back-end transactional systems, reaching all the way, every time they need something, reaching all the way back to those back-end systems. What we see emerging is this pattern where we take use change data capture to capture all of the changes to those back-end systems and represent those changes in an Apache Kafka topic in a stream of events. Because all of the changes have been captured, this means that any number of applications can then come along, read from that change log, and effectively reconstruct the data in their own personal local cache. And this is the name for this activity is actually taking a projection of the data. What this means is that each application that takes a projection of the data has a local copy of the data that it can read as many times as it needs to. It can absolutely hammer it for the data, and every time it's reading, it doesn't actually impact the back-end system. So it's able to go high speed, high throughput, low latency reads of data for the application. It can also customize the projection. What that means is it doesn't have to recreate the data exactly as it is. And this has huge efficiencies in terms of like how you write your applications. Now, thinking about how that then extends onto a multi-cloud environment, which is that bottom diagram here. Actually, what we're seeing is that this is a perfect pattern as we start hosting more of our digital applications in public cloud environments, but haven't necessarily moved our transactional backend systems from our on-premise data centers. That actually this same pattern works really nicely, where you can take that change data feed from there, replicate that out to as many data centers as you need, and your applications can read take a projection from the cache in that local data center. So it makes a perfect pattern, not only for those high data usage applications that we're doing, where we need really low latency for the end user experience. So things like an online mobile store, for example, where people actually care about being able to scroll through and get in, like be able to see things instantly. That this is becoming a really important pattern that's emerging. So moving on to the second pattern on the next slide, what we can see here is, here we go, is an additional or another kind of quality that we're looking for in our in the digital applications that we're building is responsiveness and ability to react to what's happening in the world around us. And I think this is probably most exemplified as we think about omni-channel experiences. And so a recent experience that I have had is, well, I say recently, it was before we all got locked down, but booking an airline ticket. So you might actually be browsing a website and you're making a plane reservation. So you select your route, select your plane, and then you place the booking. I think it was within 5 seconds I felt my phone buzz, and the frequent flyer app had already kind of been notified that I had made a booking, and it had already kind of registered all the details of my booking on the frequent flyer app, and it was offering me things like ability to select my seats. It was like seeing whether there was any upgrade options for me, and this kind of omni-channel experience where you make a booking over one channel and then you instantly are able to interact with it over another is inherently event-driven. So the role that technologies like Event Streams plays in this is essentially as an event distribution layer. Everything that happens in any system gets kind of fed into Event Streams, and you can use those events to trigger interactions with your end user. This becomes especially interesting when we think about not just like the simple trigger action type of mechanism, but actually when we can combine events from various sources. So maybe it's a booking has been placed, but also we have a geolocation event that person is in a particular location at that time. Maybe they're near a particular retail store that we have, and we want to kind of tie these things together and offer a more timely and relevant interaction with that customer. So the ability to kind of collate all of these events together such that you can kind of process them in one place is another important event-driven integration pattern that we're seeing more of, driven by the need for responsive and interactive applications. So the third pattern is a slight of a tangent. So on the next slide, what we have seen before is around ways that we are driving new application workload, but actually event-driven is also kind of bringing together like the applications that we're building with the kind of analytics that we're also providing, and really starting to bring the kind of application and data space together a bit more. So technologies like Kafka and Event Streams are excellent at high bandwidth feeds of data into data lakes. So that you might imagine this is all of your kind of retail transactions that have happened throughout the day, or even in real time as they are happening, being kind of collated into one big ingest pipe and fed into a data lake, such that you can do some kind of batch analytics on that, maybe mine it for kind of particular patterns that you want to then inform maybe your next quarter's marketing campaigns or promotional offers that you want to make. Kind of extending on from that, what we're seeing is that same feed of data that's going into a data lake. As we spot patterns that are coming in the batch analytics, it turns out that we identify situations where we want to actually react to the situations in real time. And so this is where technologies like streaming analytics comes in. They're able to kind of take a continuous stream of events and actually spot the situations as they happen. So we can take kind of real-time actions as a result of them. So we see an extension of the analytics use case going on to feeding stream analytics, and that drives typical new events that are going to drive interactions with users. A great example of that has actually existed for a while along these lines is actually the way that we can get kind of real-time offers produced at the checkout. So the events of kind of scanning items at a checkout kind of triggers certain combinations to be recognized, combined with any information we already have about that particular shopper, means that we can then, as we're printing the receipt, we've already decided maybe a particular real-time offer that we want to make to them at that time. And so this kind of pattern enables that. A further extension from this is around using this to feed AI. So anything that we come up with from our batch analytics can train machine learning models, and we can take preemptive actions off the back of things. So it's starting to bring in a certain amount of AI. Now, what is it about Apache Kafka that it makes it very suitable for these kind of use cases? In essence, Kafka has a lot of properties, a lot of interesting properties, but the key ones that makes it particularly suitable for these three integration patterns are the fact that it has a stream history. What I mean by that is it keeps effectively an indefinite log of all of the events that have happened, and then such that applications can come along and replay them should they need to. It has a very scalable consumption model, and I'll talk about how that works in a little moment. But also the data, the events that are written to Apache Kafka are immutable, and what that means is that the data itself can't change. A new event can happen that supersedes an old event, but the data doesn't change, and that makes it incredibly easy to scale the technology out, as in that distributing data use case, where we can replicate that data very reliably and quickly to a whole raft of remote locations. In terms of how Apache Kafka works, it's very different to how traditional queuing technologies work. So things like MQ or such and so forth. The way that Kafka works is, in a topic, it's effectively a continuous append-only log. And so as an event occurs, it gets written to the log, and you can see the representation at the bottom there. You've got kind of record 0, 1, 2, 3, 4, 5, and 6. Now, in order to actually get the be able to distribute these events to multiple consumers, rather than actually sending each of them a copy that they can then consume, it takes a different approach. Effectively, each of the consumers reads from the same logical record on the Kafka topic. So that, and if you've got multiple consumers, multiple subscribers to the data, they're reading from the same log. They're just at different points in that kind of stream of events. So in the example here, what we can see is we've got two consumers, A and B. Consumer B is slightly further ahead at offset 5, and consumer A is a little bit further behind at offset 2. So there's logically one copy of the data that everyone is reading from. And because there is effectively one copy of the data that everyone's reading from, this makes scaling out in terms of increasing the number of consumers much more efficient, because we're not making n copies of the data. Now, a question that we often get asked is, well, okay, that's how Kafka works, but how does it fit with those traditional messaging technologies like that we're used to that do queuing exceptionally well, like MQ? And actually, on the next slide, I'd like to talk a little bit about the qualities that queue-based asynchronous software has and event stream-based asynchronous software has, and why we see them as complementary. So, from a queuing point of view, the things that are really important here is when you ask for when you put a message on a queue, you're expecting something to happen. So that might be you want an order placed, or you want a transfer to happen, or things like that. So where you're requesting something to happen, you want to make sure that that request definitely ends up with the person that can action it. So you need something that can route the data to the right place, as well as assure that it will be delivered once and only once. And that once and only once assured delivery over an asynchronous medium and unreliable network connectivity is vitally important to what makes queuing useful within application development. Obviously, you are also interested in maybe like hearing back once that request has been actioned. So facilities that support kind of request response delivery patterns are also incredibly useful. And these two particular features are really, if you like, what you hopefully recognize as the standout features of MQ within the IBM portfolio, where we've really majored. Now, thinking kind of slightly more broadly about kind of being able to disseminate information to a large number of subscribers, obviously both queue-based messaging and event streaming supports PubSub type delivery, supporting delivery of messages to multiple consumers. But obviously in an MQ setting, these are delivered, multiple copies are made and delivered to each consumer for them to consume at their own pace. This has the advantage that you get more control and more visibility as to who has actually consumed the data, who is consuming the data, and when they have actually consumed it. But it comes with the cost that multiple copies of that data is made. As we move on to kind of the use cases where event streaming is more useful, this is where things like the single copy of the data that everyone is reading from gives us a more scalable consumption subscription model. And then that stream history is what we need for enabling those kind of data distribution use cases, where occasionally we might need to rebuild our cache. So we need to start all the way back from the beginning and replay the entire log. That's why those kind of qualities are very, very important. So hopefully this illustrates why we don't just have MQ or just have Kafka within our IBM's portfolio. We absolutely see and feel the need for both of these technologies because we see all of the use cases that I've just described being important. And actually for us, the focus area has been around ensuring that there is supported connectivity between these two technologies. So to highlight this with a real world example from one particular client that we're working with, we've got an airline example here, which is where this airline, their transactional systems, which manage things like plane rotors and the actual ticket reservations that people are making, the kind of information that you absolutely want to have transactional rigor around updating and making sure it's accurate. All of those systems are built actually connected with MQ. However, they had a particular goal of interacting with clients ahead, as soon as they recognized that their travel plans were disrupted, and they wanted to do that in a way that was both real time, offered the user an opportunity to reaccommodate their travel plans, and then obviously feed that back into the backend system. Now, the way that they achieved this actually is kind of at a high level depicted on the next slide, where their backend systems are all connected with MQ, all of their like flight status and reservations, and everything that they knew about where the aircraft was essentially fed into event streams from their transactional backend systems. Once it was in event streams, actually the digital applications that they were building looked for situations that arose in those events where they could spot not only that someone's plans have been disrupted, but also they could have with pretty high degree of certainty, they could preempt someone's travel plans being disrupted by spotting kind of 2 or 3 chains back in a particular plane schedule that it was delayed, and then predicting the knock-on effects. So that was a streaming analytics application that they built on top of event streams. And with that, they used that to drive mobile applications that would actually interact with the users whilst they were either in the terminal or maybe even before they arrived at the airport, and advised them of the situation and proactively presented them with 2 or 3 alternative routes that they could take. once the traveller had selected their alternate route, actually the instruction to update their booking had to flow back into their back-end systems. The reason I like this example is because it illustrates why we need to enable kind of bi-directional communication between the digital applications that we're building on top of technologies like Kafka and Event Streams back into the transactional systems that we have at the back end. So that's a quick summary of, I guess, the key event-driven use cases and illustrated in the content, like in the instance of this example that I've given here, which is an airline example. But we see these use cases being incredibly put to incredible use across a whole range of industries, not least retail, because hopefully, as some of the illustrations I gave in the upfront examples, you'll recognize that a lot of the digital disruption that's happening within retail is reliant on kind of up-to-date data being readily available at low latency. And we're constantly looking for more and better ways of interacting with our customers, be it over loyalty apps, mobile apps, kind of triggered by kind of either in-person interactions or digital interactions with them. So that's why these event-driven use cases are becoming more prevalent. So moving on to what we have done with Event Streams and how it relates to Apache Kafka. So Apache Kafka is the open source technology which is effectively become the de facto standard for building these kinds of applications upon. With Event Streams, this is IBM's distribution of Apache Kafka. So we take the open source project that we have contributed to over a number of years now, and on top of that, we build a number of key features that we believe make it easier and a lot more efficient to use in the context of an enterprise. So as a quick summary, this boils down to a user experience that is targeting not only making the operations of this more efficient, but also the development of applications more efficient to do for the users of Event Streams. So we've put a lot of focus on the user experience here, making it not only kind of easy to use, but actually all of the tasks that you need to perform are kind of right there, like for you to be guided through. In terms of ops tooling, automation has been the name of the game here for us, and actually we use a lot of the features of Kubernetes using an operator specifically to automate the deployment and management of Apache Kafka. So what we do here is basically enable things like the repeatable and reliable and consistently secure deployment of Apache Kafka into an environment. And you can, each time you can templatize this, so each time you make a deployment, you get the exact same configuration deployed appropriately to guarantee you the availability characteristics you're looking for. We obviously have features like schema registries and what have you that actually help you build applications on top of Apache Kafka, and we support geo-replication, i.e. the ability to replicate data between Kafka clusters for both availability reasons, for taking advantage of multiple data centers, or for DR kind of reasons. Connectors, I'll say a little bit more of in a second, is really important for us, that connectivity, how you can tie it into what you have already, so you don't need to rewrite what you have in order to take advantage of some of these patterns. And all of this is wrapped up in the support, the same level of and style of support that you're used to across all of IBM's integration products. So just to touch on kind of three main features, three of those features, and just give you a little bit more information. On the next slide, I do want to highlight that IBM has got a huge amount of experience with Apache Kafka as a technology. We were the first vendor to offer this as a fully managed cloud service in IBM Cloud. And a lot of what we learned in operating Apache Kafka with 5 nines level of availability for our clients on IBM Cloud is what we have then embedded in the software as we offer it as part of the Cloud Pak for integration. One specific example of this that I like to describe is the way that we enable what we call zero downtime upgrades. And what I mean by that is you can continue to increase the version of Kafka that you are running in your event streams cluster without your applications actually experiencing any downtime. And the way we achieve that is we are rolling the updates across the Kafka cluster, kind of broker by broker. And this is something that we had to perfect as part of our multi-tenant service, because obviously, as you might imagine, there isn't an opportunity to schedule downtime when you've got hundreds of tenants all sharing the same cluster. It just doesn't work. On the next slide, just some couple of examples of what we've done around operations tooling. As you can see, we have a toolbox of productivity tools that allow you to both starter application, connectivity, and workload generation applications that allow you to actually test the scale of your cluster. And then in terms of actually helping you be productive, being able to visualize the data that is flowing through your Kafka cluster, being able to kind of see a histogram of where there are peaks and troughs in workload, being able to inspect individual partitions, seeing how busy each is, and being able to drill down to the individual message on each partition, helps you both in terms of development, because you can actually validate the data that an application is writing, but also from an operations point of view. If you find that a consuming application is stuck at a particular offset, you can use that information to drill into that exact message, inspect the payload of data, and use that to decide what remedial action you need to take. So the entire UI has been geared around those kind of operational experiences. The final thing that I just kind of wanted to highlight, actually, it was the last thing that I said on the summary slide, which is the connectivity, which is on the next slide. Connectivity for us boils down into three main paths. We support, obviously, what we consider Kafka native connectors. So this is the Kafka Connect framework, a set of connectors that connect kind of run within that framework and connect to a variety of other kind of sources of events or places that you might want to put events. So in Kafka terms, sync connectors. There is a connector catalog that you can find within our documentation, and all of this is supported. And again, we provide operators to help you manage this environment. It's very, very easy to do. But for us, this is only part of the integration story. The next part is what we've got is a more ubiquitous interface for systems where maybe you want to be pushing data into Kafka, and maybe you can't actually deploy a Kafka native connector in that environment. So we're thinking specifically of like mainframe type of environments with running Kix applications, maybe lockdown appliances, or maybe applications that you just don't want to change that much, or are written in languages where there isn't a particularly up-to-date Kafka client available for them. In all of these situations, we provide a very scalable and reliable REST API as part of event streams for basically connecting to events that may be occurring anywhere in any existing system. And then finally, within the broader IBM portfolio, we look to make sure that we have native integrations from basically a whole range of IBM technologies that feed into, that can then natively feed into event streams. So this might be everything from our IoT platform and our IoT message gateway. Might be our streaming analytics service that is actually able to natively consume events straight out of event streams. Obviously, the entire Cloud Pak for integration we are heavily integrated in, and via specifically our App Connect suite, we effectively have connectivity to unlimited numbers of systems, pretty much whatever you want to, because we've made sure that App Connect can connect natively and nicely to event streams, integrating to the way that it works. And then finally, all of those change data use cases that I've mentioned, while we do have some basic change data captures that fit within the Kafka Connect framework, IBM's broad range and very complete range of very efficient change data capture suite of products in our data portfolio are ones that you can use. And again, they natively integrate not only with event streams, but also the schema registry that we have in order to make the use of that combination particularly nice for those data distribution use cases. So that was a kind of whistle-stop tour of the high-level features and areas that we have spent a lot of time adding to the basic Apache Kafka, the basic Apache Kafka project, to help make it easier to adopt this technology within an enterprise setting. The last area on the next slide that I was just going to mention briefly is the fact that it's not just about the technical features, it's also about the expertise of building kind of applications and architectures on top of this. And so a lot of the experience that we have from I've started to accumulate or have accumulated over many, many years of building these, we've started to document those common patterns in our IBM's Architecture Center, which is a free resource that you can go and look at and learn about these patterns. So I wanted to highlight that it's not, for us, it's not just about the technical features of the product, it's also about the expertise that we and our partners can bring to solutions built with event streams. So that's been a lot of talking from me, but hopefully that's useful to help you understand the kind of use cases and patterns that we see this technology being employed into, and the kinds of situations we see as being most appropriate. But why don't I hand over to Jamie now, who can actually give us some real-world examples of particular projects that he's been involved in. So Jamie?
Yeah, thanks a lot, Alan. So we kind of covered a little bit around the concept of event-driven integration, the technology, and that's great. It's been really, really interesting, and thanks, Alan, for that. But I guess the next stage is, how do we bring this to life? So one of the things that IBM has been working on, both with our Hursley labs, with different customers and partners such as Prolifics, but also with some of our garage team that focus mainly on event-driven integration use cases, is try to come up with a few industry-specific use cases that event streams or Kafka could be utilized for. So 2 or 3 of them that are coming out quite prevalent at the moment are reacting to events in real time as they happen. So one of the key ones at the moment we're focused on within retail is around inventory visibility and supply chain. So how can I react to real-time supply chain or inventory changes, such as somebody buying some stock in store and connecting the in-store POS system with the real-time stock system to be able to better replenish or service the customers to make sure that I've got things in stock. Delivering responsive and personalized customer experience. So this is mainly around you may be collecting a range of clickstream data. So this is focused around what customers are doing on the e-commerce platform or website. So you can start understanding customer buying behaviors and customer insights. Very prevalent at the moment for retailers who are looking to retain more customers rather than get new ones. Obviously, we always want to get new customers, but at the moment, I think in the current dynamic, there's a kind of sense that if we could maximize revenue from our existing VIP customers, that could be a really good way of maximizing revenue. So can I better understand my customers and their buying behaviors? And uncovering new insights. So this is more around if you're doing something around AI, if you're doing anything around machine learning. A couple of specific use cases are around monitoring. So how can I get real-time monitoring updates so I can kind of reduce mean time to resolution or better service my customers from an SLA perspective? So there's a range of use cases that we're focusing on now that I think are really prevalent in retail. So what we've aimed to do is take these use cases and build what we've called accelerators around these. So if you take one of the value propositions I just mentioned around real-time stock, what we've built is a pre-canned engagement which looks to accelerate a first solution build in around 6 weeks. So this is where we'll look to use some design thinking methodologies. So we use a tool called Mural, which has been actually really good over this period of being able to do it more virtually rather than face-to-face. We aim to look at what the use case will be and go into a kind of a stakeholder analysis as to what the business problems are and come out with a hypothesis or a business problem statement that we want to prove. We then go into what are the architecture considerations. So Alan talked a little bit around some clients want this as a managed service. We have a range of other clients who are more sort of adopting a hybrid architecture. So they may want to deploy elements of our capability on AWS because that's where some of the applications are sat. Or they may also want some to be sat on-premise as well because they've got some on-premise systems that they want to be talking to. Then we look at kind of the infrastructure build. So what would it take for us to build the use case and the architecture patterns that you want into a platform? And then we'll look to do the solution build. So this is a problem statement of, can IBM accelerate a retailer's implementation of a real-time stock integration solution using Kafka? So we're really starting to try and bring this to life. And the aim here is kind of our IBM Garage methodology: start small, fast fail, and get quick value. And then what are the other use cases that we can bring into it so that you're not trying to do a massive transformation all at once? And the engagement that we have been utilizing for this is called event storming. So this is where customers will be coming in and saying, you know, I want to do something around event driven. I'd like to build a solution, but maybe I don't know where to start. So this is where we're using sort of domain driven design, sticky notes, building a picture of what a potential use case could look like. And this is known as our event storming workshop. The first workshop is free of charge, and it's just a way of putting some ideas on a whiteboard so that you can better understand what things might be a good use case, but also, as important, what things might be a bad use case, and are mainly more leaning towards traditional integration methods or more API-led or more messaging-based. So this is a really good way to start going over what the business case and use cases might be that you could look to start on. So what does this kind of implementation journey look like, I guess? So I touched upon one of the accelerators here, but the event storming workshop is all around establishing your priorities, developing personas. So, you know, a developer will have slightly different requirements to an architect. Line of business may have a real interest in this, especially around real-time inventory. So potentially supply chain directors and supply chain teams would want to come in. And then we start doing an analysis to define an MVP scope to address. We then, like I said, we want to do this learn fast, this kind of agile iterative method, which is known as the MVP build-up. So this is where we start giving some of the knowledge transfer and sharing expertise to build some foundational skills. And we want this to be a quick win. So we don't want to go into the business and say, we want to invest in a new technology stack. Here's a PowerPoint of what it could do. This is all around something tangible, starting small, that can really demonstrate some value. And then you quickly find that some of the other stakeholders who you're trying to convince of this as an approach start to really understand and, I guess, fall in line with the way that you want to do it. And then there's a lean program. So transform and scale. So once we've got one use case and we've built an MVP, where can we take this next? So leveraging the initial pilot success and increasing agility, because as I said, people who potentially hold the influence to get something like this in have seen the value in a working MVP, so they are better equipped to make a decision on this from an investment point of view. And this is a kind of example that we did pre-lockdown, where you can see here we've got a kind of 2B scenario, and we're starting to map on these sticky notes what use cases could be viable, what problems people have. So by role, there might be 5 or 6 different problems, and then encompassing those in a stakeholder journey map to identify which one we will start with, and then what use cases 2, 3, and 4 might look like. So as you can see, it's a really collaborative way, and we've been trying this in a virtual sense, and it's been coming out really, really well. Some of the use cases that we've got, specifically around inventory and clickstream data, we're building a pre-canned MVP so that we can give clients an easy way of accessing an MVP that's already been pre-made by our development team. So there's also a consideration around, you know, this is quite a new technology for a lot of organizations, and potentially need to lean on some expertise of IBM's to know where to start. So as well as looking at the delivery options and understanding what use cases could be viable, we've also gone away with our development team in Hursley to understand what different configuration sizes might look like, depending on how resilient you need it, what kind of throughput you might need, whether you're looking at a high availability or a DR configuration. So this is really good, because I think if there's an organization that we've worked with that potentially doesn't have the expertise in this sense, we can maybe give some recommendations based off sizings that we've seen in different organizations, but also ones that we've used and proved with our Hersley lab development team. So this just gives a kind of starter for 10, so that organizations can maybe have a good idea of what configuration size might be. So one of the use cases that we've worked with is a large worldwide grocer. What they were looking to do, they wanted to extract some information for their supply chain. So very similar to the real-time inventory use case I mentioned before. And they also wanted to capture data around successful use of coupons and advertisements. So again, starting to get more into engaging differently with customers. You know, Alan talked a little bit around this sort of log and replay of what customers have done. So you can actually go back in time to see what some of your VIP customers might have been looking at, and maybe offer a personalized discount or something like that. So this was more around trying to get a more accurate information of promotion successes, and also connecting their supply chain better in real time. So whether it's the real-time stock, whether it's the warehousing, the e-commerce site, maybe they've got some things around a chatbot to help customers, getting a single source of truth and connecting that data in real time at scale is proving really advantageous. Another really interesting one is the RFU. So for those who know the RFU, they obviously are the governing body of England Rugby. And IBM actually did a garage engagement using this design thinking methodology to build a real-time data stream layer. So all of the real-time in-game data that you'll see, very similar to what IBM does with Wimbledon, goes through IBM Event Streams, so that you can start analyzing large kind of sets of data and start doing some AI or machine learning around it, all in real time for the consumer or the viewer to see it as the game is going on. So my last slide is just to note that the IBM Event Streams technology that we've spoken about today is just one part of a wider integration story that we're seeing. So many, organizations, especially retail, are still going to have traditional legacy systems, and so traditional integration methods are still going to play a part. We're seeing a massive shift towards APIs. I guess the API market has now been around for a few years. So we kind of believe that there's more than one integration pattern that will play a part in an organization's challenges. So the Cloud Platform integration is a single platform, one sign-on, where from one pane of glass you can access different integration capabilities dependent on your use case, all readily containerized so that you can deploy on-prem to a mixture of the clouds that you can see at the bottom, or a hybrid model as well. And it comes out of the box at no additional charge with Red Hat OpenShift as well, which is obviously the leading management tool for containers. So you can start deploying chunks or containers of the capability in real time very quickly. So you're focusing more on the high profile, high value tasks rather than spending more of your time provisioning infrastructure. So I will pass on to Alan, to Kim, sorry, and he will talk a little bit around how events plays a role in the wider Agile integration story. Thanks, Kim.
Thank you. So I've been working for about 20 years or so in this space, and doing a lot of, in more recent years, workshops with customers around how their landscapes are changing from an integration perspective. And we talk about this now as Agile integration. That's a term being used more generally across the landscape. And if we just step onto the next slide, Agile integration comes in a number of different aspects. There's a number of different pieces to it, if you like. Right through from things that are around people and process and method, through to how architecture is changing, and indeed the technology underneath it. We mentioned things like OpenShift for containers and things. And so really Agile integration is a way of looking at where you are today in terms of integration and looking at where you're heading to. And it's somewhere along that journey that people are starting to take a closer look at event-driven architecture. Which is kind of a cyclic thing. Event-driven architecture itself is perhaps a couple of decades old, but it's come to a resurgence recently because of its relationship with things like microservices architecture. If we've been talking about a reference architecture, around 2016 we put out this reference architecture, which is very much a kind of layered architecture where you can see the different sort of specialisms very well sort of pointed out, and that's typical of how organizations were and still are aligned in terms of being aligned through the technology specialisms. But if you go to the next slide, how we would propose to sort of look at a reference architecture today would be more around business components, business applications and components, rather than layers of technical specialism actually wrapped around sort of what does the business do and how is that pulled together. And so that plays a lot more into giving business teams greater autonomy, allowing them to decentralize the organization so that teams can fulfill their own needs in terms of, yes, building applications and building solutions, but those solutions include integration. And so they're going to need to be able to provision their own integration capabilities. And very much what we've been looking at with the portfolio is moving in that direction. So making it possible for a much broader set of teams to expose APIs, to consume events, to build event infrastructures and so on. And so that's become really fundamental to the way that we're building the capabilities like that now. So this, if you like, is a very high-level maturity model for integration. And I'm not going to go through it in huge detail today, we don't have time, but you can see there's sort of 4 stages from the left-hand side, very typical centralized enterprise service bus. And as we move across, we start to see the introduction of API management for exposing APIs outside the organization. In the third column, we start to see the first evidence of not events in the sense that we've been talking about them today. So although you can't see it particularly well with the coloring on the screen today, on column 1 and 2, we do in fact have asynchronous communication going on, perhaps using traditional messaging, as Alan alluded to earlier, like IBM MQ. But in column 3, we're starting to see some usage of event streams on the far upper right towards the microservices application. And in the fourth column, event streams are becoming quite fundamental for how applications communicate with one another across this much more decentralized enterprise, an enterprise that's perhaps spread out into the cloud, perhaps into multiple different vendors' cloud environments. And so we start to see how having that more decoupled way of communicating across those and using things like the event history that's provided, which is something that's really fundamental to the way that eventing is done in the Kafka space, really allows us to do some different models to we would have been able to do before. There's an interesting thing around scale here as well, because what I'm looking at here is we're kind of standing back 50,000 foot and looking at an enterprise as a whole. If you step onto the next slide, and you'll see here that if we zoom inside an individual microservices application, there's a usage of events in there as well. So we start to see the event broker being used inside what we call a bounded context of an application to allow us to do new patterns in there too. So events are being used within applications and across enterprises, and the patterns look similar, but they're actually subtly different. And so again, it comes back to something Alan mentioned, that there's and Jamie as well, that there's a lot of experience needed to implement events across an enterprise and within applications to understand how these patterns come together. Number of different patterns that we talk to clients about currently. Regularly we hear things like patterns like event sourcing and CQRS. I've put some references to some webinars where I talk in a little bit more detail about that, and we've got a good reference architecture site there as well. But these sort of patterns are, some of them are at the application level, some of them are at the broader enterprise level, and mechanisms for using and getting the best out of this modern style of event-driven architecture, seeing exactly how that benefits you in a way that events of the past wouldn't have been able to, because they're a slightly different mechanism for providing the asynchronous communication. What we're seeing across all of the clients I talk to be fair, is that APIs are a very, very powerful way of making data accessible very, very quickly with a very simple programming model. It's very straightforward for a consumer to use an API. It's going to be something, it's certainly going to be a path that we'll take for the simplest exposure of back-end systems and the simplest communication between components. And that's not going to go away. We're going to continue seeing lots and lots of use of APIs. But alongside that, we're starting to see event stream consumption as well. And events allow us to do things in a way that might potentially provide for a higher throughput. So some of the patterns described by Alan earlier on would have enabled you to satisfy orders of magnitude higher requests for data, because you perhaps listened to an event stream, built up a local data store of the information you need, a cache if you like, but it's subtly different to a cache, and then be able to surface that data at a much, much lower latency than you would have otherwise been able to do. And certainly without the availability concerns and performance concerns you'd have had if you used an API, where the API has to traverse in real time all the way through to the backend system. It's trusting that the backend system is there, that it's sufficiently available, that it's sufficiently performant. Instead, with the events, the information is being delivered up to those microservice applications or other components as the changes occur. So most customers we're speaking to at the moment are moving from perhaps where they were sitting in an API economy, to exposing everything as an API, perhaps coming out of the back of service-orientated architecture and looking at this sort of API economy concept. And they're saying, well, that's good, but it's not providing everything we need, and we need also to complement that with event-driven consumption. And so they're starting to see a mixture of both of those as satisfying the full set of needs for connectivity across the enterprise. So one slide further, and I've been talking a lot about Agile integration. Again, really not time available to go into this in detail, but it's looking at a broad range of changes you can make to your integration landscape, event-driven enterprise being just one of those, that allow for a more productive workforce in terms of that decentralization I was talking about, in terms of being able to deliver changes more quickly and efficiently, the solutions you build being more robust, so being able to decouple yourself more effectively from back-end systems, have a resilience model that's more fine-grained on the individual functions that you're exposing, and have more efficient provisioning. So just both in terms of being able to provision something quickly, it not necessarily needing a specialist team, and that ultimately sitting on a platform that's able to elastically grow and change as the performance demands change from one application to another. So it's making really good use of the cloud infrastructure sitting underneath it. Just briefly mention this customer in the UK, retail customer in the UK. They've been championing Agile integration right from the beginning. They're using Cloudpack for integration, and they've had some significant benefits. A headline item from their perspective was that it used to take them literally months to provision new environments and get new things in place. And through a suite of changes they've been making along the path of Agile integration, they've now got to a stage where they can technically push out a new environment fully secured and ready in a matter of minutes. And that's a testament to them as well for really focusing on changing their processes and improving their automation. But it also is very much focused on taking on these new styles of integration as well. So just some references there for you around Agile integration and generally on the Cloudpack. And I think we've got about 4 minutes left if there are any questions that anybody wants to raise, either by coming off mute or if we've got anything that anybody's seen in the chat.
A couple more points from me before I pass to Hannah for closing remarks. Just want to say thank you for joining from our end. I will make sure that everybody who's attended has access to the information. One of the last takeaways I would say, we will add the link into the architecture center that IBM has put together around event streams. There are a number of different event-driven patterns and use cases that go into very relevant retail specific use cases that I think would be a good afterthought as well if people wanted to find out more. So Hannah, pass back to you.
Great, thanks, Jamie. Yeah, I just really wanted to say a big thank you to both Alan and Kim for speaking today, and Jamie for putting this together, and for all you who came out and attended. I hope you found it interesting and insightful. Thanks so much.